In a right triangle ABC in which angle B is equal to 90 degree, a circle is drawn with AB as the diameter. So let me draw a rough diagram. Not able to exactly get. This is B, that's A, and that's C. The circle is drawn with AB as a diameter. Okay. So something like this. Okay, let me do that actually. This though we understood, right? We'll draw that first. So this we have the diameter, and this would be our base. Something like this, I guess. Okay, let me do it till here. And this I'll join it. That was our hypotenuse. This is 90 degree by the way. And that's our A, B and C. Okay, intersecting. Okay, a circle is drawn with AB as the diameter, intersecting the hypotenuse. What is intersecting? The circle is intersecting the hypotenuse at P. It's very important for us to mark this. That is our point P. Prove that the tangent at P bisects BC. Okay, let me use this color. Let me draw a tangent. Something like this, I guess. That's supposed to be the midpoint. So what they're telling is this point M, I'm calling it as point M, that is the midpoint of BC basically. Right, so this is your question. So your question needs the diagram. So you guys have to make this as part of your answer. Let it be. Now, what are the few things we can join? Few obvious things. OP, O being your center, we'll join this, and we'll join this also. That is PB. PB also will join. Anything else? We'll call, let M be the point of intersection of PC and the tangent. To prove PC bisects or tangent bisects BC. That's it. And the proof. Okay. So how will we go about doing this? We have to basically prove that this length is equal to this length. How will we relate this to? That's the question, you know. That's the main question. All this, that is okay. How do we relate it? So what I'm thinking is something like this. I'm thinking in this line. So let me just do this. Why is it not visible? Oh, okay. Just a second, guys. Now it's visible. Right? We have to relate this triangle with the neighboring triangle. Can we prove that they're congruent? Maybe not. Or we have one more thing. Both these triangles have one thing in common. What is it? Yes, we have PM in common. So somehow if I relate BM to be equal to PM, and if I relate PM to be equal to MC, I am done. How will we relate this? They look like isosceles triangle, so it has to do with angles. So let's talk about angles over here. So we have OP is a what? We have OP to be the radius with respect to the tangent. So that is 90 degree. We'll start off with calling this as theta. Right? If you guys don't want theta, I can call it as X also. Not an issue. So if that is X, oh no, you guys are in 10th grade. You should know theta. theta, so that would be theta, this would be 90 degree, and this would be 90 minus theta. We have OA being equal to OP. Why? They are radius, so this also will be 90 minus theta. Okay. Then what to do? We have OB is equal to OP. Of course, I can't take this as theta. I should be taking this as, say, x. Right? So this also will be x. Agree again because of radius, and this is an isosceles triangle. This particular angle will be 90 minus x. Okay. Then what else? What else can I do? Wait, this is 90, so this will be 90 minus x. Okay, since this to a 90 minus x, this will be equal. These two sides are equal. We just proved that this is an isosceles triangle. And moving on to the other triangle, since this is a, wait, let me go to the other layer. This entire thing, let me use another color. White, I guess. Are you guys able to see that? Or black? I think black. This entire thing is equal to how much? 180 degree. We have 90 minus theta, x, 90 minus x, so x and x will get cancelled. 90 and this will add up to 180 degree. So this has to be equal to theta. Because this is theta and this is also theta, what happens? We have these two sides to be equal, and so we have the proof. That's it. Okay, there's a lot of writing, I understand. I'll just take it slowly. I kind of proved it, not kind of proved it, I did prove it. We just have to take it slowly. Okay, let me write it slowly for you guys. First we'll call let angle C be equal to theta. Okay. So with this in mind, if we go to in triangle ABC, the entire big triangle, right? What do we have? We have angle C plus, or I'll just go with angle A is equal to 180 degree minus angle C minus angle B. This is because of angle sum property of triangle. Angle sum property of triangle. When we substitute the values, what will we end up with? Angle A is equal to 180 degree minus angle C, that is theta, this is 90 degree, and so this is equal to 90 degree minus theta. Okay, so this is 90 degree minus theta, this is theta, and so on and so forth. And next we'll write the obvious. We'll call which one? Triangle OAP. Okay, so we'll talk about triangle OAP. In triangle OAP, what do we have? We have OP is equal to OA because they are radius, and so from this we can imply what? We can imply easily that angle OPA is equal to angle OAP is equal to 90 degree minus theta. Reason: angles opposite to equal sides are equal. Angles opposite to equal sides are equal. Okay, and then we have our next triangle is OBP. We'll consider triangle. In triangle OBP, here again we have OB is equal to OP, they are radius, and so we have angle B, no, not angle B, OBP is equal to angle OPB, I think so. Yeah, so both are the same reasoning. Okay, so we'll call this as X. Let angle OBP is equal to X. This implies Angle OBP is also equal to x. Right, guys? And then we have in triangle PMB. So it's a slow writing, a lot of writing. In triangle BPM. So what do we have? We have angle MBP. MBP. I'll copy the diagram actually. Let me copy the diagram. It's very convenient. Yeah. So we are looking at triangle BPM. In this case, what is that we are going to do? We have to prove that this set of angles are equal. So we'll start off with angle MBP, which is equal to angle ABC minus angle ABP. So this is 90 minus x. Okay. Then we have angle BPM. Okay, guys. So this particular angle, right? That is equal to what? That is equal to angle correct. Angle OPM, sorry, minus angle OPB. Okay. So this is 90 minus x, right? So reason tangent is perpendicular to radius at the point of contact. Is it not? Point of contact. So with this reasoning, this will be 90 and this is x. Agree? Again, I'm trying to cut short the writing. If you keep writing every possible thing, it is too difficult. Okay, and then we have, yeah, and then we have the following. What is it? This implies angle MBP is equal to angle BPM, right? This in turn implies what? This is therefore this in turn implies side BM is equal to MP. PM is equal to MP. This is because of angles opposite to, not angles, sorry, side opposite to equal angles are equal. Sides opposite to equal angles are equal. And then on to the other triangle. So what do we have? In triangle PMC. Okay. So we need the diagram again actually. What are we looking at? PMC. PMC has to do with, here we have to take up the angle, this angle MPC. So let me consider triangle angle MPC. Angle MPC is equal to 180 degree minus angle BPM, agree? BPM minus or brackets plus, or no, let me just go with that. I want to reduce the writing. BPO again, please slow down and have a look at each angle, whatever I'm telling. Minus angle OPA because of APC being a straight line. APC is this is because of APC being a straight line. Okay, and now we have angle MPC is equal to 180 degree minus 90 minus x plus x. Then we have minus of 90 minus theta. A bit of simplification and we'll get this to be equal to theta. 180 degree minus 90 plus x. Oh, sorry, this is minus, by the way. Minus x minus 90 plus theta. And now we have minus 90, 180 degree getting cancelled. X and x getting cancelled, and we have this to be equal to theta. And therefore, angle MPC is equal to angle MCP. Both are equal to theta. And this implies side MP is equal to MC. So this is because of, we know the reasoning. We have already written it once, that's enough. So we'll call this as 1 and 2. We'll call this as 1. Where is the 2? This is 2. And from 1 and 2, what do we have? We have all of them to be equal to each other. And so we have the answer, that's it, from 1 and 2. Again, thinking wise, it's very simple if you have a very good diagram. But writing wise, it's lengthy. So MP is equal to BM is equal to MC. And thus BC is getting bisected at M. That is, BC is getting bisected by the tangent, right? And we have the proof, hence proved. That's it. A lot of writing, a lot writing, but yeah, this would be your answer. Again, first I had a very small circle, which you guys have seen in other questions, but for this question I needed this. And you can see the reasoning, because we are dealing with angles and they need a very clear cut writing, where what should go and which sides are equal. So again, give priority to a big diagram. If not for this diagram, I won't be able to do this answer for myself itself. It's difficult. Okay, now you can pause and have a look at the answer. Try it yourself. At least with the diagram, writing part, you guys will find it very easy. If you're able to think, then this is very simple. Yeah, pause.